Dear students, let us begin the second part of the lesson in which you will learn about the estimating the parameters of mean and variance of sampling distributions. Researchers typically use sample data to estimate the population parameter value. This process is called estimation. The estimates are classified into two. One is point estimation and the another one is interval estimation. Point estimation: approximating the actual value of the parameter from a random samples of the population. Point estimation is the process of finding an approximate value of some parameter such as the mean of a population using an estimating function which is called estimator of sample observations. Interval estimator or confidence interval. This defines a range within which the value of the parameter can be expected to fall with a specified degree of confidence. Methods of point estimation. There are several point estimation methods, including the method of maximum likelihood, the method of least square, the best unbiased estimator, and others. All of these methods allow you to calculate estimators. In order to establish credibility, an estimator should satisfy certain properties. The desirable properties of an estimator are consistent. By increasing the sample size, the sample estimator provides estimated value close to the true value or actual value. Unbiased. An estimator T is said to be unbiased if expectation of T equal to parameter value, that is, expectation of statistic equal to population parameter value. The estimator is said to be unbiased. Desirable properties of an estimator. When these two properties are met for an estimator, it is the best unbiased estimator. Of all consistent unbiased estimators, choose the one that is most consistent and unbiased. Efficiency. An estimator is said to be efficient if, in the class of unbiased estimators, it has minimum variance. It is called more efficient since it has the smaller variance. Sufficiency. An estimator is sufficient if the sample contains adequate information to estimate the parameter. As a result, any new sample information is redundant. The most commonly used estimators are mean and standard deviation. Sample mean x bar is the estimator of the unknown population mean mu. The sample mean possesses all the above desirable properties. It is an unbiased estimator of the population parameter. But in the case of population standard deviation sigma, the estimator sample standard deviation, that is denoted by small s, is a biased estimator. Point estimator of the population mean mu. The sample mean is the best point estimator for the population mean mu. To get a sample mean, select a sample of size small n, where x1, x2, etc. xn are the data points of a sample. The formula to compute sample mean is x bar equal to 1 by n summation I is equal to 1 to n xi. Population mean mu unknown. Population mean mu is the average or expected value of some quantitative variable calculated from the population. It is unknown, and the value of it is to be estimated from the sample values. Examples: the mean lifespan of some bacteria, that is, the mean life of bacteria is unknown, that we have to estimate. Another example is the mean income of government employees in India. We cannot calculate the mean income for all the employees in India. Therefore, we take a sample. From the sample only, we estimate the average income of the entire India. Groundwork for point estimator of the population mean mu. Here certain notations we are going to use. Population distribution is expected to be normal distribution. The population mean is denoted by the letter mu. Population standard deviation is denoted by the letter sigma. Random sample is of size is taken for the study. From that, we calculate sample mean x bar and the sample standard deviation small s. Procedure: draw a random sample of size n, that is x1, x2, etc. xn from the normal population of size capital N. Now, we are interested in estimating the population mean mu. For that, x bar is equal to 1 by n, sigma I is equal to 1 to n xi is used as a point estimator of mu. Interval estimation. It is another procedure to estimate the parameter. According to this method, we find an interval L, u containing the true value of the population parameter mu with probability 1 minus alpha percentage confidence level, where here L stands for lower limit of the confidence interval, u stands for upper limit of the confidence interval, and 1 minus alpha is confidence level. Interval estimation. The procedure of it: if x1, x2, etc. xn is a random sample of size n drawn from the normal population with parameter mu and sigma, then calculate the sample mean x bar to get 1 minus alpha percentage confidence interval under the condition sigma is known or given. The formula is x bar minus z1 minus alpha by 2 into sigma by root n. Upper limit is x bar plus sigma 1 minus alpha by 2 sigma by root n, or this can be simplified in a compact form as x bar equal to plus or minus z1 minus alpha by 2 into sigma by root n, where z1 minus alpha by 2 is the value taken from the normal probability table. When sigma is unknown, in the formula sigma is replaced by capital S. As the result, the lower limit is x bar minus z1 minus alpha by 2 into s by root n. The upper limit is x bar plus z1 minus alpha by 2 into capital S by root n, or this can be written in a compact form as x bar plus or minus z1 minus alpha by 2 s by root n. Here x and z can be calculated using the formula x bar is equal to 1 by n sigma I is equal to 1 to n xi. S squared is equal to 1 by n minus 1 sigma I is equal to 1 to n xi minus x bar whole square, and on simplification this formula will become as sigma xi square minus nx bar square by n minus 1. Note: when sigma is known, the value of sigma is used in constructing the confidence interval. When sigma is unknown, its unbiased estimator value capital S is used in constructing the confidence interval. Students, I hope you understand all the concepts. We will continue in the next video. Thank you.